In this video, we're going to learn about trigonometry. Specifically, we're going to learn some new words like sine and cosine and see how all these relate to a right triangle. A right triangle is, again, one where one of the angles is 90 degrees. So the motivation behind these is often when you're looking at a triangle, you might want to see how the sides compare to each other. For example, here, this side is 3 units long. This one is 6 units long. So you might want to, think about how this one is half as big as the other one. So in general, before we talk about what sine and cosine specifically mean, let's get to how we label some of these things so that we can define sine and cosine a lot more easily. So looking at this triangle, let's say I pick this angle, and let's say this angle is 30 degrees. Now, if I want to talk about this angle and how the 3 sides relate to that angle, well, let's see, out of the 3 sides, 2 of these sides are sort of touching that angle, touching that 30-degree angle. So the one that's not, the one that's sort of across from it, is called the opposite side. So this one over here is the opposite side. Now, out of the 2 remaining sides, one of them is the hypotenuse, right? Because that's the hypotenuse is always generically the biggest side or the one across from the 90 degrees, right? So this one over here is the hypotenuse, HYP for short. And then finally, this other side, it's sort of next to that 30-degree angle, right? Not opposite from it. And so the one that's next to it, there's a math word for it, or just an English word in general called adjacent. That's the one we use here. So adjacent means right next to, opposite is across from it, and hypotenuse is just the biggest side there. So now that we have these labeled, we can talk about the definition of sine and cosine. So sine in general, so first of all, notice that it's incomplete. If I were to just ask you what's sine, that's like, what is the sine? That doesn't make sense. It's always the sine of a specific angle. So here, if I'm talking about this specific angle over here, well, then the side that's opposite to it divided by the side that's the hypotenuse of that right triangle, that ratio, that opposite over hypotenuse, is the sine of that angle. So just to apply it to the specific numbers here, we could sort of make a mathematical statement based on this. We could say that the sine, using this right triangle, we could say that the sine of that angle of 30 degrees, notice, by the way, this is not multiplication. This is not sine times 30 degrees. This is sine of 30 degrees. So the sine of 30 degrees, we can say, is equal to the opposite side, which is 3, divided by the hypotenuse, which is 6. And heck, if you wanted to, you could even simplify that and say, hey, 3 over 6 is a half, or 0.5 or a half, however you prefer. So now you could make a statement that you sound fancy saying the sine of 30 degrees is a half. And that's fine. And what that means is, of course, that for a 30-degree angle, the opposite side is half as big as the hypotenuse. But anyway, the cosine, now the definition of cosine is, if you had this length over here, you'd be able to say that the cosine of that 30-degree angle is whatever that adjacent length is divided by the hypotenuse of 6. Now let's talk a little bit more generically. So here, instead of a specific angle like 30 degrees, what if I called this angle over here x? So this is x degrees. And this other angle over here, y, like it's y degrees. So the angles can be variables too. What if the sides here were 3, 4, and that the hypotenuse is 5? Now let's use what we just learned, the definitions, to figure out what is the cosine or the sine of x and y degrees. So first, let's do the cosine of x degrees. So the cosine, remember, is adjacent over the hypotenuse. So the adjacent side to x degrees, specifically the adjacent one, the one next to it, is 4. And then the hypotenuse is, of course, just 5 here. So the cosine of x degrees in this triangle is 4/5. And similarly, if we were to look at the sine, then the sine of x degrees, well, let's see, the sine is the opposite. So here the opposite is 3, and it's the same denominator for both sine and cosine, right? It's 5. So this is going to be 3 over 5. Right? Now, in the same triangle, what if the angle we were focused on instead of x were this other angle, y? Well, now we have to change our mindset about what's the opposite side. So notice, it's not like this side is fixed as the opposite side in this triangle. It's opposite relative to x, but it's adjacent relative to y. So now if I were to find the cosine of y degrees, the cosine of y, well, now the adjacent is the 3. and the hypotenuse is still 5. So the cosine of y is 3/5, adjacent over hypotenuse. And similarly, the sine of y degrees. So now for y, the opposite is 4, and then the hypotenuse is 5. So 4/5 is the sine. And notice here, what's always going to be true is that within a given triangle, if you look at one angle versus the other, the sine of one angle, like the sine of x, is going to equal the cosine of the other angle within that right triangle. But you don't need to worry about that for now. That's just a conceptual point here. But the key is, don't mix up which side is opposite or adjacent. Keep in mind what angle you're looking at, right? So it depends on the angle. Now, speaking of angles, one final point here is that I'm using x and y here as the variables because that's what you're used to for the angles. But what math people like to do is there's a Greek letter called theta. It looks like this. It's like a little zero with like a line through it. So like theta is often the variable of choice for angles rather than x or y. And so here, if I were to give you that these sides were A, B, and C units long, and if I were to ask you here, what is the sine of theta, meaning this specific angle in this triangle? Well, the sine is going to be, let's see, opposite is A, hypotenuse is C. So the sine of theta for this triangle is A over C. Notice we don't even need numbers here. We're just now thinking generically. We're using the definition. The sine of theta is A, opposite, over C, the hypotenuse. And finally, here you could say that the cosine of that angle, theta, is the adjacent side, which is B, over the hypotenuse of C.